Good morning, boys and girls. It's Mrs. Grinstead again. I hope you're all doing well. I really do. I miss you, but let's get right into this week's lesson. This week's lesson is going to be on breaking apart arrays to make multiplication easier for us. It's a review lesson, so I'm hoping that if I go through a couple examples, it's going to refresh your memory and you guys are going to be good to go. So let's jump in and take a look at the first example. If we want to multiply 6 times 7, we need to be thinking, which factor? I can only break up one of them. So which factor is going to be easiest for me? And this may differ for everybody depending on the facts that you already know. So I'm going to think aloud. If I have 6 times 7, one way to do it would be to break apart the 7. So I drew my array. And I have 1, 2, 3, 4, 5, 6 rows with 1, 2, 3, 4, 5, 6, 7 in each row. If I'm going to break apart the 7, I keep my first factor, 6. My 7 became 5 plus 2 because 5 and 2 make 7. So 6 times 1, 2, 3, 4, 5 plus 6 times 2 gives me 6 times 5 was easy. 5, 10, 15, 20, 25, 30. So 30, 6 times 2, my doubles, 6 plus 6 is 12. 30 plus 12 is 42. So I know 6 times 7 is 42. Drew my array, broke apart one factor, solved a simple problem to get my product. Not the only way you can do that one. 6 times 7. That 7, I might like my 4 and 3 tables better. And if I'm good and fluent with my 4 tables, watch. So now I have my same array, 6 rows, 7 in each. But now I have 1, 2, 3, 4 in this one, and 3 here. So I broke it to 6 times 4, 6 rows of 4, plus 6 rows of 3. I solved my 6 times 4 is 24, plus my 6 times 3 is 18. 24 plus 18 is 42. Again, 6 times 7 is 42. Notice here, I chose this 7. I could have broken it up into 6 plus 1. There are many ways to do this. It all depends on what facts you know. Come this way. Maybe I wanted to break up the factor 6. So now I'm breaking up the number of rows. I drew my same array, 6 rows with 7 in each, because that is my big problem. But now I'm breaking apart my 6. And I think doubles, 3 plus 3, I can do that. So I said, okay, 6 rows. Now I'm going to break it into 3 rows with 7 in each, and 3 rows with 7 in each. So now I have a new problem, 3 times 7 plus 3 times 7. Now I only have to do one multiplication problem, because it's a double fact. If I know 3 times 7 is 21 here, it's 21 here. 21 plus 21 gives me 42. So again, 6 times 7 is 42. In my head, I would be thinking of breaking the 6 apart to my 5 plus 1, because I can really easily skip count 5, 10, 15, 20, 25, 30. So I know my 5 facts, and I know anything times 1 is itself. So here, same array, 6 rows, 7 in each. But this time I'm breaking it apart. So I do 1, 2, 3, 4, 5 rows and split it. Now I have 5 times 7 in each one, plus 1 row with 7 in each. 5 times 7 is 35. 5, 10, 15, 20, 25, 30, 35. Plus 1 times 7, which is itself 7. 35 plus 7, again, is 42. 4 different ways to break apart 6 times 7 and still get the product of 42. Let's take a look at another example. Okay, what if I wanted to do 9 times 6? Now I know my big problem here is 9 rows of 6 in each. So I'm going to come down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I have my 9 rows with 1, 2, 3, 4, 5, 6. Now my array looks like this. 9 rows with 6 in each. So I know my big problem, that's a lot to count. I don't want to do that one. So I'm going to think in my head. I'm going to think. And here's my bubble to think. Now I'm going to think, which factor do I want to break apart? 9's kind of big, so 6. Whoa, I already know 6 can be 5 plus 1. So I know 5 facts and I know my 1 fact. That's what I'm going to do. I'm breaking apart my 6. So what am I going to do? I have my 9 rows, but now I'm going to have 5. 1, 2, 3, 4, 5. 5. So here I have 9 rows of 5, which is 9 times 5, plus, here I have 9 rows of 1, which is 9 times 1. Now I know 9 times 5, I can skip count 5, 10, 15, 20, 25, 30, 35, 40, 45, 9 times. I get 45. I know anything times 1 is itself, so 9 times 1 is 9. 45 plus 9 is 54. So I know 9 times 6 equals 54. Again, there were other ways I could have done this. I could have broken that 6 into 3 plus 3. And that would have changed my new problem. It would have been 9 times 3 plus 9 times 3. Then I would have got my 27 plus 27, and I would have got 54. So many different ways I can think. I could have thought 6 equals 4 plus 2. Would have changed my problem. It would have been 9 times 4 plus 9 times 2. And I would have got my 36 plus my 18. And again, I would get my 54. So multiple ways of doing this. Let's try one more before we do a word problem. Ready? What if I take, I'm going to do it in a different color. What if I take, and I take 7 times 8. Now I want to do 7 times 8. Here we go again, ready? So 7 rows. So here we go. 1, 2, 3, 4, 5, 6, 7 rows. Now I got to go 8 across. 1, 2, 3, 4, 5, 6, 7, 8. My graph paper, grid paper makes it easy, but you can draw your lines to get this done. So I have 7 rows with 1, 2, 3, 4, 5, 6, 7, 8 in each row. I don't want to count all those squares. Way too long and too big of a chance me making a mistake. So what am I going to do? I'm going to break one of these apart. And I'm going to, again, think. 8, 4 and 4. I don't really know my 4 tables great. 7. Wait a minute. 7. 5 plus 2. If I break about my 7, and I know 7 can be 5 and 2. So now I'm going to break apart my array, and I'm going to say I have 7 rows, but I want to have 5. 1, 2, 3, 4, 5. So if I break apart here, I have 1, 2, 3, 4, 5 rows and 2 rows. So now I'm going to have 5 times, still have 8 in each row, plus my 2 rows, still have 8 in each row, times 8. Now 5 times 8. 5, 10, 15, 20, 25, 30, 35, 40. That's easy to skip count. Plus 2 times 8. I can either skip count by 2s or I can say 8 plus 8 is 16. Now I know 40 plus 16 is 56. So 7 times 8 equals 56. Just another way. Draw an array to make it a smaller, easier problem so that you are more apt to get it correct Because counting all these squares takes a lot of time. Breaking apart is going to help you solve multiplication problems quicker. We're going to end this week with a word problem because throughout some of the sessions, you're going to be asked to complete some word problems. Again, using the multiplication breaking apart strategy to solve them. So if I take a look at this, Mark orders 6 boxes of lollipops. There are 9 lollipops in each box. How many lollipops did Mark order? Well, I can think in my head, 6 boxes. Here we go. 1, 2, 3, 4, 5, 6. I have 6 boxes. There were 9 in each. 9 here, 9 here, 9 here. This is now showing equal groups. And we know equal groups means multiplication. So, my problem to find out how many lollipops did Mark order is going to be 6 boxes with 9 in each, and I am going to want to find the answer. Here we go. 6 times 9 would be my 6 rows. 1, 2, 3, 4, 5, 6 rows with 9 in each. 1, 2, 3, 4, 5, 6, 7, 8, 9. I make my array. 1, 2, 3, 4, 5, 6. So there's my array. Now I got to think, what factor am I going to break up? I, in my head, think 6 is an easy one because 6 can be 5 plus 1. So if I decide to break apart 6 to 5 plus 1. 5 plus 1 equals my 6. So here we go. Instead of 6 times 9, that 6 became 5 plus 1. So now it's 5 times 9 plus 1 times 9. And on my array, I'm breaking my rows. So here we go. I'm going to break 1, 2, 3, 4, 5 rows. I've got 5 rows of 6. Sorry, of 9. 5 rows of 9. Now I have 1 row of 9. 5 times 9 is 45, plus 1 times 9 is 9. What do I have? 45 plus 9 equals 54. So I know how many lollipops did Mark order? Mark ordered 54 lollipops. So you're going to be working on this week, lesson 7. The pages are up on the website. And go through everything that you can. Do the best that you can. Go back to drawing it, breaking it apart, double checking, doing it a different way. Instead of 5 and 1, maybe I could have done it 3 and 3. See if I get the same answer. Make sure you're right. Don't forget about extra math. Don't forget about your 45 minutes of iReady each week. You guys now have laptops, so you should be able to do this. And hopefully I'll get to see you guys soon. Okay, take care.